Hello, everyone, and welcome, and thank you very much for joining our Pre-Milled Blank, Elos Accurate Pre-Milled Blank Key Features and Benefits webinar. I am Stephen Boers, the Commercial Product Manager for Elos, and I will be giving a short introduction to today's webinar before I'll pass the word to my colleague Mo Albana from the States, who will then guide you through the rest of the webinar. Before we start the webinar, I would like to remind everyone that our Elos Accurate Pre-Milled Blank is part of what we call our Elos Accurate Digital Smart Flow. So it's an important component in the whole flow or solution. And a couple of weeks ago, we did our first webinar in a series of webinars on our ScanBody 22. Today, we will go to the manufacturing side and look closer into our pre-milled blank. Also important, and something I would like to remind everyone of, is that we have a lifetime guarantee for our Elos Accurate products. That means for our products, but we also offer a guarantee for the dental implant, actually. So that's just as a reminder that we are also very much focused on making sure people get a guarantee. To finish off, I would just very quickly like to go through today's webinar, or the topics that we will be looking into today. So we will focus, as I said, on our pre-milled blank. And Mo will tell us more about how the technical specs of our pre-milled blank actually ensure that you get a predictable outcome when you mill your customized abutments. He will also go a little bit deeper into how our pre-milled blank solution will help you overcome some design and manufacturing challenges that you might be experiencing today. On top of that, he'll talk about some more technical features and benefits of our pre-milled blank. And he will also touch upon the subject of compatibility, because compatibility is key. The importance of a validated workflow is also very important when milling customized abutments. And I can already say now, and Mo will tell you more about that, that we have an FDA cleared validated workflow. At the end of the webinar, we hope there will be some time for some Q&A if any one of you would have some questions. I would like to ask you to write your questions in the question box that you will see on the top of your screen. And then we will try to handle as many of them we can within the time frame at the end of the webinar. If we can't answer them all today, then Mo will note them down and get back to you afterwards. Also important to mention is that you can obtain CE credits for this webinar, and at the end of the webinar, Mo will explain you how to get those CE credits if you're interested. And with that said, I have come to the end of my part of the presentation. So I will now pass on the words to my colleague Mo, who will continue with the rest of the webinar.
Awesome. Thank you very much, Steve. I appreciate it. Thanks for the great introduction. And for time purposes, but just please remember, again, we will not have time to answer questions as we go along, but we will be more than happy to answer everything at the end. And if you guys remember any other questions later, please shoot me an email and I'll be more than happy to respond to that.
First, I would like to remind everyone that our peak scan body, or the IO line, which many of you might be familiar with, has phased out as of August this year, and it is being replaced with ScanBody 22, or our titanium scan body that we have discussed in details in our previous webinar. Elos Accurate Pre-Milled Blank Solution. Let's start by discussing some specifications and key benefits. Maximum stability design, which is in the mandrel area. That's the guide lock clamping system that ensures high stiffness, which is essential for precise, predictable, consistent results. Laser marking with lot and item number. That's not only for identification purposes, but also for regulatory traceability. Maximum design freedom. That's the gingival height for much better design ability, which I will discuss further in the next slide. Smooth transition zone. That's referring to the feature that would reduce the manual finishing after the blank is milled. Full compatibility, that's referring to the blank screws which have a precise seating area that is identical to the original screws. The blanks are all manufactured from biocompatible grade 5 titanium, and the dimensions on all of them are 18 millimeter for the millable part. That's 18 millimeter in height. The diameter is 12 millimeter and the mandrel is 10 millimeter. Finally, the Elos blanks are all FDA cleared blanks. Coming back to the gingival height, the Elos pre-milled blanks pretty much have a gingival height of 100 microns or 0.1, where the competitors tend to stay between 300 microns to 500 microns. The smaller the gingival height, the better aesthetics that we can achieve in designing the crown. So obviously by having a much higher gingival height or much wider gingival height, that kind of complicates the design or limits the design capability or ability for the end user to achieve aesthetic results. And looking at the screws and the compatibility of the screws, if you look at the seating area for both screws, the Elos screw versus the original screw, for example, the seating area is exactly identical, where some of the competitors have a flat seating area, which can result in screw loosening or even breakage at some point. Now, digging back or coming back to the guide lock clamping geometry or system, the guide lock clamping system has been meticulously engineered to achieve optimal stiffness. The stiffer the blank, the better the performance, or the better the accuracy. And if we see here, the cutout in the mandrel ensures that the screw firmly pulls the blank towards the module body, securing the blank in the slot as it is being guided by the pin right here on the bottom of the slot in a precise path. So as you slide the blank into the slot inside the module, the pin here will give you a lot better guidance in where that blank needs to precisely go. And then when you screw the screw from the top, which sits at 45-degree angle, that ensures that the blank is butted precisely or firmly against the body of the module. And that's the general principle of guide lock. There is a few more things that we will discuss in the next few slides to actually break the guide lock principle a little bit more. So looking at this diagram here, blanks mount outside the holder for easier access and stronger clamping. So the module actually comes outside the holder completely to give you a lot easier access to mount your blanks. Connection supported by both mandrel and the widest diameter of the blank's back end. So basically, once the blank is fully engaged inside the slot and you screw the screw in, then the widest part of the back end of the mandrel here butts or presses firmly to the body of the module, as you can see where it's highlighted. Guide lock principle: the 45-degree angle on the screw secures the blank on a flat-to-flat surface, ensuring high stiffness. So this principle right here, when we have the screw at a 45-degree angle and we tighten it and we're pressing the blank firmly towards the body of the module, that gives us a lot more stiffness, which is essential for a lot more consistent, accurate milling or results. The guiding pin ensures a precise rotational alignment via machined geometry, not drilled, to reduce tolerance in the rotational alignment of the pre-milled blank. Meaning the pins right here that you see inside the module or inside the slot on the module, that helps to guide the pin through this groove on the bottom of the mandrel. These pins here are machined in within the module itself and not necessarily drilled in. If you drill them in, then we're increasing a lot more tolerances to the mix, which would make achieving accurate results much more complicated. So these pins again are machined as one piece along with the module itself. And if we look at where these where the pen or how the pen guides the blank, these are the tips of the pen. They engage inside that groove and they kind of guide the blank, the sides of the blank precisely into the slot, into a perfect position from all angles. And it's not going to be like lopsided or angled or anything like that. It's going to go straight in and the screw will just ensure that it is firmly pressed to the module. As we can see here, the blank will slide into the slot, being guided by the groove and the pin under the groove underneath the mandrel and the pin here, and then we bring in the screw at a 45-degree angle to ensure the final tightness or the final firmness that we need to have the blank in the module for the best accurate or most accurate results. Precision milling and clamping. Rigid, precise clamping is essential to avoid blank deflection. So as the machine is milling the blank, if we continuously get deflection because the blank is not secured firmly inside the holder and the burr keeps disengaging from the blank and then having to re-engage, then that will cause much less accuracy and less consistency on the results, if not burr breakage at the end. Deflection leads to tool re-engagement, higher tool wear, much higher noise, and reduced accuracy. When you have quiet milling process, that's an indication that the blank and the tool are fully engaged the whole time with no deflection. And if we look at this diagram to talk about some tolerance and alignment control, the challenge was to precisely get the module inside the holder with the X, Y, and Z play when placing the module into the holder. The solution was constraint design, and the constraint design is actually an engineering term, with small protruding tabs from the back, the side, and the bottom. So these blue or the highlighted blue tabs here is what we're talking about. These protruded tabs is what helps the module gets in a precise position every time under the constraint design to ensure the accuracy and the predictability every time we take this module out and back into the holder. And there are 3 tabs also on the bottom that we can't see in this picture, and they are placed precisely underneath each slot. So under the slot there is another tab on the bottom side. So there are some on the back, the sides, and the bottom. Holder frame and modules machined as one piece for perfect alignment and repeatable accuracy. Modules can be swapped between positions and holders without losing precision because of the engineering in the background when making all this stuff. Clamping advantage. Competitors clamp from the top only to make it easier but less stable. The Elos modules clamp in 2 directions, horizontal and vertical, with a dual 45-degree screws, and that concept is awaiting a patent. We submitted the forms. We're just awaiting the approval on that patent. And each module has 2 long bottom pins to stabilize the module while we're trying to screw it inside the holder, to prevent tilting and to make it easier to tighten the screws. The results of all of the above is a quieter milling process, minimal vibration, higher precision, and longer tool life. And if we look at this short video to show you what happens to the blank when you tighten the screw, and you see how the screw basically pulls the blank firmly in perfect position every time. Now, looking at the multi pre-milled blank holder, so we have 2 types of holders. We have single holders and we have multiple blank holders. This is one of the multiple blank holders. They tend to have a module concept. They tend to have a much more engineering put into them. And also specifically with the IMUS and one of the VHFs or VHF holders, we actually added a couple of additional slots for future expansions, or maybe if we decided to add something else in the future, we already made the room for it, so that kind of makes it future proof. And because of the way everything is made, these modules can be swapped from one side to the other without any problem, or from one holder to the other without any problem. Also, all the screws on the modules and the holder utilize the Torx 20, so it's one tool for everything without having to change different screwdrivers for different things. And by the way, the screws that hold the module in place, they're kind of embedded into a deeper socket to prevent loosening in case of vibration or whatnot in the milling process. So by having the screw kind of sink in, it keeps it a lot more secured in place, and it's not going to come loose in the milling process. Now, this is the single blank holder. It obviously does not need all that advanced engineering. It's a lot simpler. It still utilizes the couple of the main concepts. So for the single blank holder, like I said, no need for the advanced engineering and no module constructions. The connection is supported by both mandrel and the widest diameter of the blank's back end. So it's still the same concept where the screw pulls the blank in and the pen underneath just guides it in place. Just like we said here, guide-like principle with the 45-degree screw secures the blank on a flat-to-flat surface, ensuring high stiffness. The guiding pen ensures precise rotational alignment via the machine geometry and not drilled to reduce tolerance in the rotational alignment of the pre-milled blank, which basically I explained in simple English, that the pen guides the blank in place and it is not drilled in, it is milled along with the holder as out of one piece. Now, if we look at some of the validated workflows that we already have in the market, we already have a compliant FDA and MDR approved workflows with the IMAS I-Core, with the VHF, Plan Mecca, and the Roland. All four systems have a validated workflow already, and we are in the process right now of validating the Amann-Gurbach system as well. However, please remember that the Amann-Gurbach is still pending FDA clearance. It's in the works. It's coming in the very near future, I'm hoping. Regulatory is always a hot topic, especially for dental labs. So to reduce the risk of liability, you basically would be required to follow a particular protocol that we have established to keep you on the safe side. So you're initially using an FDA cleared pre-milled blank. You just need to combine it with an Elos validated workflow. And if you follow the recipe, you should not have any issues with the FDA producing these pre-milled titanium abutments and be worry-free completely. And here we're looking at three main components to that equation to having a validated workflow. The first one is capturing the scan data, possibly through an intraoral scanner like the 3Shape or maybe a benchtop scanner. And then you utilize the Elos library, and then you go to the design. That's the second segment. So capturing the scan data is the first, design is the second, and manufacturing is the third. So if you ensure you are utilizing the validated method of capturing the scan data, the validated method of the design software, which is either exocad or 3Shape, those are the only two that we have validated and we are compatible with. And then the manufacturing by utilizing a validated workflow with a particular milling machine such as the IMAS I-Core, VHF, Plan Mecca, Roland, and pretty soon we'll add the Amann-Gurbach system. Then by doing all that, you can ensure that you have met all the requirements with the FDA, and you can have a validated workflow overall to ensure that you have an approved pre-milled blank or titanium abutment cleared by the FDA. And thank you for listening. I hope this was informative enough. We'll get to the questions now. And please remember, for any questions that we have no time for, I will ensure that I will reach out to you. Just make sure you leave your email for me, and I'll make sure to answer all your questions.
All right, let's see. I hope that was informative enough for you guys. And we have a question here. Where do I find information on what implant systems are supported? If we go to our website, let me bring in the screen. So if you come to our website, elosmedtech.com, go to, oops, sorry, hold on one sec. There you go. So if you guys go to elosmedtech.com, dental professionals, under Knowledge Hub, there is the guides. You click on that, and then you could have download the catalog. The easiest one is the product overview because it pretty much has all of them. And then it shows you here all the implant components. Am I sharing the wrong screen here? There. Sorry about that. So it shows you basically all the implants or implant manufacturers that we have compatibility with. Right there. All right. Any other questions? My email is mo.elbana@elosmedtech.com. Please, if you think of any other questions in the next few days or in the future, send me an email. I'll be more than happy to answer. All right, at this point, I think we don't have any more questions. Don't forget to send me your CDT numbers onto my email, and I'll make sure to submit everybody's everybody's credit. So I need your name and your CDT number. Please don't forget to send those for all of you who are CDTs. And again, we have no more questions at this time. So I appreciate everybody's attendance and listening. Till next time, you guys take care. We'll see you hopefully on the 16th of October. We're going to have another webinar regarding the PMAs, printed model analogs. I hope to see you then. And for now, you guys have a great weekend.